All right, moving on to a new chapter, chapter 12. Define and use sequences and series. Let me go through some terms here with you. This is all new stuff. Reading the definitions here, a sequence is a function whose domain is a set of consecutive integers. If a domain is not specified, it's understood that the domain starts with a 1. So you can have a list of numbers that can go on to infinity or just to a fixed number, and they can start with 1 or any number. And that's going to be part of the key to this is where you start and where you stop. The values in a range are called the terms of the sequence. So let me give you an example. Let's just say for the domain we have, it's going to be 1, and then 2, and then 3, and then 4. Let me stop there. Well, the range or the output for each input of the domain will be A1 for the first one, A2, A3, and A4. So they correspond with the number. That number always comes down to be as part of the range. It'll be used in the calculation of the answer as well. Again, the sequences can be fixed. They can be finite or infinite. So down here it talks about finite sequence has a beginning and an end, and then it has infinite, which just goes on forever and ever. And just so you can tell when you see them, finite might be like 2, 4, 6, 8, and stops. That's it. There's 4 terms. Infinite could go 2, 4, 6, 8, ... and it's just going to keep going. 10, 12, and so forth and so on. Okay. And here's what you're going to start doing here in a second. This next line here. A sequence can be specified by an equation or rule. So early on, I'm going to give you the rule, and you're going to apply the domain and spit out some range. So for example, both sequences above can be described by the rule 2n, or fn equals 2n. So I put a 1 in here. I got 1 times 2 is 2, 2 times 2 is 4. I'm back up here, folks. 3 times 2 is 6, and 4 times 2 is 8. Okay, so the rule would be 2n. Alrighty? Let's try a few things here. Now, I'm not going to ask you to write all, it says here write terms of sequences. Write the first 6 terms for this rule. So let's just write the 6 numbers. I don't want you to say A1 equals, but that's just more work than we need at this time of year. What's going on? So let's just list the answers, okay? But when I put a 1 into this particular rule over here, so A1, just to show you that one example, it's going to be equal to, and now n is 1, right? You take that 1, you spit it over here. So 2 times 1 is 2 plus 5. So you put 1 in, you're going to get a 7 out, right? So the first number is 7. I'm going to just show a few of these. Make sure you got it. So when I put, the second number is 2. Well, then it's going to be 2 times 2. This 2 goes there, right? Because the n goes over there, right? That's going to be 4 plus 5 is 9. And now you're starting to see a pattern perhaps, but just to play it safe, let's just do one more here. Okay, so a to the 3 equals 2 times 3 plus 5, and that's 6 plus 5 is 11. So you can see what's going to happen, right? Just going to add 2. So 13, that's 4 of them, 15, and 17. That's 6? 1, 2, yeah, that's 6. First 6 terms. Okay, next one. Now I get a little trickier here already, but we put the numbers in. Again, they don't tell you let's say the first 6 terms, so we assume it to be 1. All right, so when I go over here, I'm going to, so they're here. I'm going to do 1 with you over here. So f of 1 equals negative 3 to the 1 minus 1. Well, that's 0. So when I put a 1 in, negative 3 to the 0. Oops, negative 3 to the 0. Let me try that again. Negative 3 to the 0 is just going to be 1, right? So my first number is 1. That's the first number in the series. All right, so let's go I'm going to erase all this, put a 2 in here. If I can do this. Yeah, I can't put it everywhere. I'll try it. So f of 2, negative 3 is 2 minus 1. So f of 2, so 2 minus 1 is 1. And negative 3 to the first power is going to be negative 3. So there's my second number in the series. The signs could alternate because, remember, when you have an odd number over here, it's going to be a negative output, of course, because you have that negative in there. So next, let's put a 3 in here. So I'm just putting the values here for you so you see it's working. Again, I just need the answers that I have circled over here. So 3, it's going to be negative 3, 3 minus 1. That's going to be 2. Negative is going to be a 9. So you start to see the pattern. You basically have 3 to the 0, 3 to the 1, 3 to the 2, correct? But the odd ones will be negative answers. Okay, so the 1, the 3, the 5 will all be negatives. So you can see you can do your answers here without going through all the calculations. It's going to be 1, 3, 9. 3 times 3 squared. 3 times 3 is 3 to the third is 27. 3 to the fourth is 81. I ran a room. 3 to the fifth is 2. Was it 43? Now again, this is a negative one. That's negative, and that's negative because those are the odd numbers if you subtract the 1. All right, so that's my answer. Hope that's okay for you. All right, let's try a few more here. Again, the first 6 terms. Again, 1, 2, 3, 4, 5, 6. You put those in for the ends on all these, just adding that number to 4. So it's going to be 5, 6, 7, 8, 9, 10. There you go. For number 2 here, put the numbers up here in the end. So negative 2 to the 1 power is going to be, the first number is going to be negative 2. You put a 2 there, it's going to be positive 4. You put a 3 there, it's going to be negative 8. You put a 4 there, it's going to be a positive 16. You put a 5 there, it's going to be a negative 32. You put a 6 there, it's going to be 64. So there's that list. Are you seeing how these go, folks?